Hello, everybody. Starting just a few minutes early tonight. I hope that's not a problem. I haven't really noticed many people attending live, so I figured it wouldn't be too much of a problem to go ahead and start a little bit early. Tonight, we're going to be going over confidence intervals, and specifically, we're going to be going over confidence intervals for the normal distribution, as well as for small samples with the normal distribution, which is the t-distribution. And so I just want to take a few minutes to quickly review what makes up a confidence interval. So a confidence interval is typically two numbers, and the way you get to those two numbers is through a series of steps. And so confidence intervals are constructed using three key pieces of different information. The first piece of information is the point estimate of our statistic. In the case of what we're going to be doing today, that's a mean, but we can also compute confidence intervals for proportions, and that's something we'll be dealing with a little bit later in the semester. Then we have a standardized distance that we'd like to go away from the mean, and that is typically a z-score. As we've talked about a lot, specifically last week, z-scores are simply a number of standard deviations. So a z-score of 1 is 1 standard deviation to the right. A z-score of -1 is 1 standard deviation to the left. A z-score of 2.5 is 2.5 standard deviations to the right. A z-score of -3 is 3 standard deviations to the left. And as you know, if we can assume that something is normally distributed, these distances and standard deviations also correspond with certain proportions. So within the first standard deviation to the left and the right, we have 68% of the sample, for example. So within z-score -1 to z-score +1, we have 68% of our sample, or a proportion of 0.68 in that bounded area. Then the third piece of information that we need is the standard error. And the standard error, as again we talked about last week, is simply our estimate of the standard deviation given our sample size, and specifically the standard error, as we calculated last week, is the standard deviation for the sample divided by the square root of the sample size. Okay, so what confidence intervals look like, again, are typically either two numbers or a point estimate with a number plus or minus after it. That point estimate, again, is our mean. And then to that, we add and subtract the standardized distance multiplied by the standard error. So the amount of distance that we want to travel, given the level of confidence that we'd like, multiplied by our standard error for our sample. And then we add that to the point estimate and we subtract it from our point estimate, and we get what are called the lower bounds and the upper bounds of the confidence interval. And what these confidence intervals do is they take the point estimate and they add or subtract a standard number of deviations to create an interval that contains a certain percentage of the observations, as I've said before. So for example, if we went one standardized distance above and below, we would get the confidence interval that would contain 68% of our sample. Now, typically, what we want are 95% confidence intervals, 99% confidence intervals. Every now and then, you'll be asked to compute a 90% confidence interval. And to calculate a confidence interval based on those steps is relatively simple, especially if you're using a program like Excel, which is what we'll be focusing on today. Essentially, what you do, as long as you have at least 30 people, which allows us to assume a normal distribution and therefore to use a z-table as opposed to t's. What we do is we compute the point estimate. So we take the average using the equals average function in Excel. Then we compute the standard deviation by taking the standard deviation function in Excel. Then we compute the standard error of that standard deviation by taking the standard deviation divided by the square root of our sample size. And then we can either look up or calculate the margin of error. So in order to get the margin of error, there's a nice Excel function. It's equals confidence.norm. You put in your alpha level. So in this case, if we wanted a 95% confidence interval, our alpha is 0.05. As you can see down here, all you do is to take 1 minus the level of confidence to get your alpha. So for example, if it's a 90% confidence interval, then your alpha is 1 minus 0.9, which is 0.1. If it's a 99% confidence interval, then it's 1 minus 0.99, which is 0.01. So you put that alpha in first, you then put in your standard deviation, and then you put in your sample size. So if you're using this, you technically don't even need to take the time to calculate the standard error, because the Excel program is taking your standard deviation and sample size and calculating that standard error for you. So all you need to know is the alpha level that you want, the standard deviation, and the sample size. And then we use the formula to add or subtract the product of the margin of error and the standard error from the point estimate. So on Blackboard later this evening, there will be an example data set, and I'll post an example data set and the data set that has answers. You can see here that I have the example data set here, and then on the other tabs, there are some additional forms with answers as well as comments in them. And so for the first one, we're going to assume that we took a random sample of 40 MPH students at Hunter from the population of Hunter MPH students. And using these 40 students, we want to better understand the studying habits of Hunter MPH students. So based on our sample of 40 students, we need to calculate a few things. The 95% confidence interval and the 99% confidence interval. Okay, so we go over here, and what we're going to do is going to be relatively simple. We've gone over things like this in previous weeks, and we're just really, each week we're building upon what we did the previous week. So if you didn't understand something from the last week, make sure that you go back and you review it and you really understand it before you try to move on to this week's exercise, because they do build upon each other. Okay, so the first thing we need to do is calculate the mean. And so here we use equals average. And then we just select all of our data. So in this case, we have 40 data points, important to keep in mind. So this is a sample of 40. You can see that I put that in the tab down here, n equals 40. Then we're going to calculate the standard deviation by equals STDEVA. And again, we're just going to select that set of values. And then we're going to calculate our standard error. Now, again, I told you before, you don't actually need to calculate the standard error in order to get this information. However, in our case, we do want to calculate the standard error just because I want you to get additional practice seeing that calculation. Again, we did this last week, but it is always good to do it multiple times. So all we're going to do is take the standard deviation, and we're going to divide that by the square root of our sample size, which in this case is 40. And that is 1.97. Okay, then we're going to calculate our margin of error. So we're going to be calculating equals confidence dot norm. And then it tells you what you need to put in, just like I did on the previous page. So first you need to put in your alpha. So we want a 95% confidence interval. So then we take 1 minus 0.95, and we get an alpha of 0.05. We then need our standard deviation. So all we're going to do is pipe in our standard deviation from here. And then we need our sample size, which we know is 40. And when you're piping this in, make sure that you're piping in the standard deviation and not the standard error. This is going to use the standard deviation plus this sample size to calculate the standard error for you. If you put that standard error in there, it's going to then divide that standard error again by the square root of 40, and you're going to get a very small standard error, and your confidence interval is going to be incorrect. So make sure that in this case, you're putting in that standard deviation. Okay, so our margin of error is 3.86. What that means is that when we go 3.86 units above the mean and 3.86 units below the mean, we have approximately 95% of our sample in there, or we can assume that we do. Okay, so then to calculate this, to calculate the lower bound, all we need to do is take the mean and subtract the margin of error. And then to calculate the upper bound, we take the mean and we add the margin of error. And so then our 95% confidence interval for this is 14.3 and 21, well, approximately 22. Okay, now we want to do the same thing, but we want to calculate a 99% margin of error. So what's going to change here? The first thing that we should take note of is whether the 95% margin of error or the 99% margin of error is larger. And then we also want to take note of how that affects the confidence interval. So we're going to do this. So equals confidence.norm. Alpha in this case is 1 minus 0.99, which is 0.01. By the way, you could also just type in 1 minus 0.99 You don't even have to type, you don't even have to do that math. Excel can do that math for you. You pipe in the standard deviation, not the standard error, and then the sample size is 40. So notice here, our margin of error got bigger. So we wanted to be more confident, and so our margin of error got bigger. Because we want to be more confident, there's also more room for error. So then we're to get the lower bound, we're going to take the mean, and we're going to subtract the margin of error. And then to get the upper bound, we're going to take the mean, and we're going to add the margin of error. Now, not surprisingly, because the margin of error got bigger, the confidence interval also got wider. So the distance between these two numbers is wider. In fact, I mean, not surprisingly, 2 times 3.86 is a little less than 8. 2 times 5.07 is a little more than 10. So it grew almost by a distance of 2 units. To go from being 95% confident to 99% confident, we had to widen our confidence interval. So it's important to keep that in mind. The more confident you are, the wider your confidence interval is going to be. That's always going to be true. To have a higher confidence level, you have to widen your confidence interval. If we did a 90% confidence interval, the 90% confidence interval would be narrower, meaning the lower bound would be higher and the upper bound would be lower. They would be closer to the mean. So the less confident you are, the closer you can get to the mean. The more confident you are, the further away you get from the mean. Okay. All right. So the next thing we're going to do is calculate the exact same thing, but we're going to do it with a sample of 80 students. So we have the same data here. In fact, I just took the data from the 40 students and I copied it again to make 80 students, just so that we can see how data with the same mean changes in terms of standard deviation, standard error, margin of error, and confidence interval. Okay, so we're going to take the mean of these numbers. And again, this time we have 80, so you have to go down a little bit further. Then we're going to take the standard deviation. Then we're going to calculate the standard error. Again, the standard error is not required here because we're using these confidence functions. However, we're still calculating that standard error because it's an important piece of practice. However, when you use the confidence interval function in Excel, it is going to calculate that standard error for you when you put in the standard deviation. So you need to make sure that what you're putting in is the standard deviation. Okay, so this is going to be equals this divided by the square root of our sample size, which is now 80. Okay, so now we have a mean of 18.13. Let's just look at how that compares to our sample size of 40. So like I said, we have exactly the same mean. So the samples have the same exact mean. So they have the same average value. However, in this case, you see the standard deviation is 12.37. Here, the standard deviation is 12.45. So the standard deviation did change a tiny bit, but not a whole lot. The next thing you see is that assuming that we had a relatively similar standard deviation, so this one's a little more than 12.4, this one's a little less than 12.4, but they're both about 12.4. So we wouldn't expect the standard error to change that much if the standard error didn't take into account sample size. However, keep in mind that what we do is we divide by the square root of the sample size. So if the sample size goes up, then the number you're dividing by goes up, which means the standard error goes down. And you can see that here. We went from a standard error of 1.97 based on pretty much the same standard deviation to a standard error of 1.38. So the standard error decreases as the sample size increases. If the data stay the same somehow, like if you drew a random sample and the data stayed the same in terms of the mean and the standard deviation, the standard error would still go down as the sample size goes up. And that's a desirable property. That's what we want. The more people we get, the higher number of people we have from the population, the more precisely we're measuring these things. And so we don't penalize ourselves as much when we calculate the standard error. And so this is why when you have a larger sample size, you have an easier time finding significant results, which we haven't talked a lot about significance yet, but this is the reason for that. The standard errors decrease as the sample size increases. Okay, the next thing we want is the margin of error. So again, we're going to do equals confidence.norm. Put in our alpha. So here I'm just going to show you, again, we can do 1 minus 0.95. So we want a 95% confidence interval. Great. All we have to do is put in 1 minus 0.95. You don't even have to calculate that yourself. Then we put in the standard deviation. Again, not the standard error. I'm pointing these things out over and over because even though I'm pointing them out, I know that sometimes people will forget and slip up. So I'm trying to, hit this home as much as possible that in this case, what we need is the standard deviation, not the standard error. And then finally, we put in the sample size, which in this case is 80. So our 95% margin of error is now 2.71. How do you think that compares to our margin of error from our sample size of 40? Well, our margin of error is just a constant number. And in this case, if you know the rule, a 95% margin of error is calculated using the z-score 1.96. So our margin of error is just a constant number, 1.96, multiplied by the standard error. And so our standard error went down, so we would expect that our margin of error went down as well. So in this case, we have a margin of error of 2.71. In our sample size of 40, we had 3.86. So that's a huge drop. That's more than an entire unit that we went down in our margin of error by doubling the sample size from 40 to 80. Then we calculate our confidence interval. It's the mean minus the margin of error for the lower bound, and it's the mean plus the margin of error for the upper bound. And so we have 15.4 and 20.8 compared to our sample of 40. It's more narrow. And this again is what we would expect because the margin of error went down. The confidence interval is closer to the mean because the margin of error is smaller. Again, a result of increasing sample size. If you increase your sample size, the standard error goes down, which means the margin of error goes down, which means the 95% confidence interval and all the other confidence intervals will get narrower. So again, the more people you have in your sample, the more precisely we believe that you're estimating the population parameters. And so the less we penalize you and the confidence interval gets narrower. Now for the 99% margin of error, we're going to do confidence.norm. Our alpha here, we're going to do 1 minus 0.99, which is 0.01. Our standard deviation, again, make sure you're getting the standard deviation and not the standard error. And then our sample size, in this case, remember that it's 80, not 40 anymore. So 3.56. Again, if we want to be more confident, we have to give ourselves more margin for error. Then to get our lower bound, we're going to take the mean minus the margin of error. And to get our upper bound, we're going to take the mean plus our margin of error. And so we have 14.6 and 21.7 approximately, compared to 13 and 23 here. So again, we squeezed in. Our margin of error went from 5 in the sample of 40 to 3.5 in a sample of 80. So this margin of error went down by about 1.5. So again, the more people that we had, the more precise our margin of error, the smaller our margin of errors were, and the more precise our confidence intervals were, the closer they were to the mean. However, to get more confident, you have to widen your confidence intervals. The margin of error grows as your confidence grows. In order to be more confident, you also have to widen your confidence interval. Now, the last thing I want to show you in Excel is doing this with a sample size of 20. So a sample size of 20 is smaller than a sample size of 30, obviously, and 30 is the minimum for using the normal distribution. And so in this case, we're going to be doing the exact same thing, but we're going to be using the t-distribution. And the t-distribution is going to adjust for the fact that what we're using is a small sample that may not be totally normally distributed. It's unlikely with such a small sample that you have a normal distribution because you don't have enough people to really fill out that random probability. Okay, so here, oops, excuse me. We're going to take the mean of our data equals average. And in this case, again, we only have 20 cases. So our mean here is 15.5. Now don't try to compare this mean to the previous ones because these are totally different data. These data do not match the previous examples, so don't think that having a smaller sample size increased the mean. That's not possible if you have the exact, although you can't have the exact same data with a different sample size. But my point is the mean didn't change as a function of the sample size changing. The mean changed because the data changed. So do not try to compare these to the previous ones because they're not really comparable. We're using different data in this case. The point here is not to compare these with the previous. The point here is to show you the t-distribution being used as opposed to the normal distribution being used. So we calculate our standard deviation, and then we calculate our standard error, which is just the standard deviation divided by the square root of our sample size, which is 20. Our standard error here is 2.8 approximately. Then we're going to calculate our margin of error by using equals confidence dot t. Make sure you're using the t-distribution if what you have is a sample size smaller than 30. I am sure that probably in the assignment and or in the exam, there will be a question where the sample size is smaller than 30. You're going to need to pick that up on your own, that the sample size is smaller than 30 and that you need to switch from the normal distribution to the t-distribution. That will probably be something that can trip you up if you're not paying enough attention to notice that the sample size has gone down. So be on the lookout for that kind of thing. Then we need our alpha, so we do 1 minus 0.95, our standard deviation, and then our sample size here is 20. So here our margin of error is 5.83. Our 95% lower bound is going to be the mean minus the margin of error. And our upper bound is going to be the mean plus the margin of error. And so this is a pretty wide confidence interval. With a mean of 15, we have to go all the way down to 9 and all the way up to 21 to create our 95% confidence interval. And that's because our margin of error is relatively large here. And now we know that the margin of error is going to get even larger when our confidence level goes up. So to make a 99% confidence interval, we're going to have to go even further from the mean. So here we're going to do confidence dot t. Our alpha is 1 minus 0.99, which is 0.01. Alpha here equals 0.01. It's important to recognize the fact that alpha is the term we use to indicate 1 minus our confidence level. Standard deviation. And our sample size again is 20. And so now our margin of error is almost 8 here. So we have to go pretty far away from our mean to create our confidence interval here. Equals the mean minus 8 equals the mean plus approximately 8. Okay, so we have a very, very wide confidence interval here, as you can see. To be 99% confident, our confidence interval goes from 7.5 to 23.5 almost. Okay, so that is what I wanted to show you. If you download this from Excel, you'll see that pretty much everything that I remarked on as I was going through this is listed here with little comments in the tabs that say answers in them. So let me just make this bigger for a second. I don't know how easy it is for you guys to see at home. I can zoom into the spreadsheet, but I can't really zoom into this menu bar down here. But you'll see n equals 40, n equals 40 with answers, n equals 80, n equals 80 with answers, n equals 20, n equals 20 with answers. The ones that have answers obviously have answers. They also have some notes in them that you might want to look at. So that's just some helpful information for you guys. Okay, then the other thing that I want to show you is how to do the same thing in SPSS. So I brought in the same data from our sample of 80 into SPSS. Unfortunately, again, I can't really zoom in on this. Let me just adjust my resolution quickly so that hopefully this gets a little bit bigger for you guys. Let me see what this does. Okay, so that made things a little bit bigger. Hopefully that makes them a little bit easier to see, the SPSS. It looks actually like it's maybe a little bit more blurry than usual now. I apologize for that, but hopefully you can at least see these menu bars a little bit better and see what I'm doing. So like I said, we have our data set of 80 here again. It's the same data from the 80 tab in Excel. And what we want to do is just calculate the same exact thing. So we want to calculate the standard deviation, the standard error of the mean, uh, and then we want to calculate the 95% confidence intervals and the 99% confidence intervals. All right, so the first thing we're going to do is go to descriptives. So let me actually just take a moment. It's been a long time since we've worked in SPSS, so I just actually should remind you quickly. We have our two different views in SPSS. We have our data view and our variable view. Variable view shows you all of your variables and their properties. So in this case, we have only one variable. Its name is hours. Again, because the problem that we're working with is the number of hours students spend studying. It's a numeric variable. It's 8. It can be up to 8 characters wide with 2 decimal places, although in this case, we only are using up to 2 characters wide with no decimal places. I can put in a variable label here for you so that we get a better sense of what this is. It's good practice to put in variable labels when you are using SPSS. So I'm going to put in number of hours student spent studying. There's no point in putting value labels here because remember, value labels are really for categorical variables when you just have a few different numbers representing a few different groups. So for example, if we had gender, we might do 1 and 2 for male and female. Or we might have race and we might have 6 different categories of race, in which case we're still going to give those groups numbers, but then we're going to use this value labels function here to assign those numbers labels so we know what they actually mean in terms of groups, because we know that the numbers themselves don't mean anything. Missing values is a similar thing. I'm not going to go through that right now. And then measure. For this case, we have a number of hours, which is hopefully relatively normally distributed. So I'm going to go ahead and say that that's a scale variable or a continuous variable. And then we go back to our data view, and then what you see is our variables are across the top, making our columns, and then our rows are each individual case. And so because we have 80 cases of data, we have 80 rows here. So this is actually a little more intuitive than in Excel, where if you want to put a label at the top for your variable, then you actually end up one row longer than the number of data points that you have. So in Excel, we're often going down to the 81st row to get to the 80th data point. In SPSS, you don't run into that problem because the variable name is kept separate from the actual rows of data. And so the 80th row means the 80th case as well. All right. Then you remember we have used the transform menu to calculate and do some things with variables. We've used the graph menu to go into legacy dialogues and do a few things. You can do some scatter plots there, histograms, box plots. Those are some of the most common things that we would use. And then the analyze menu is really the most commonly used menu. And the descriptive statistics is all we've really focused on so far. And that's what we're going to continue to use again today. So I'm going to go into well, you can actually do this really in both places, either the frequencies or the descriptives. I'm going to use the frequencies menu. I like it a little bit more, but I'll show you how you can do this in both. You pull in the variable that you're interested in. In this case, we only have one variable, so it's pretty easy to find into our list of variables. Then you go into statistics, and we're going to ask for the mean. We might as well go ahead and ask for the median as well, the standard deviation, the standard error of the mean. Hit continue. And then I'm just going to go ahead and ask for a histogram too, just so we get a look at that. And then I'm going to hit paste so that it gives me the syntax to do that over again if I want to. And I'm going to run that. And so here you can see SPSS has given us this information. We have a mean of 18.125. Standard error of that mean is 1.38257. The median here is 18.5. And the standard deviation is 12.366. Now this should match what we had already seen in Excel in our 80s. So 18.13 and 18.13 if you round. Standard deviation 12.37, 12.37 if you round this. Standard error 1.38, 1.38 if you round this. So not surprisingly, we would be in trouble if we were getting different numbers from Excel and SPSS. Luckily, we are not. Oh, and see, it's a good thing I did this histogram, because actually we are not really meeting the assumptions of the normal distribution. As you can see, this variable is not normally distributed at all. So, as an example, we're going to continue running these things assuming a normal distribution, but in real life, in practice, you would want to look at this and realize, oh, actually, this is not a normally distributed variable. I should really not be making assumptions of normal distributions with this variable. Okay, the next thing we're going to do, I'm just going to show you how to do that same thing with the descriptives menu. So you go to descriptives and you move in the variable. Then you go to options, and here's where you choose what you want to see. So the mean is already selected, the standard deviation is already selected. Also, it's selected the minimum and the maximum. And then you also want to select the standard error of the mean. Notice that the descriptives menu doesn't give you as many options. So for example, I don't get the option to export a histogram. And there are fewer types of statistics here. So if you noticed in the frequencies menu, we had things for calculating percentiles. We had, we also had skewness and kurtosis in the frequencies menu. So pretty much anything that you can get here, you can also get in the frequencies menu. However, the frequencies menu, the only thing, it gives you more options. So in addition to the things you can get here, it gives you some other options, as well as the options of putting out charts, which is why I typically use the frequencies menu regardless of whether I'm looking at a categorical or a continuous variable. The only option that the descriptives menu gives you that the frequencies menu doesn't is to save standardized values. Saving standardized values means that for each person, they're going to take their value on the variable and it's going to be converted into a z-score. And so what that means is a score of 11 is going to be converted into where that falls on the distribution in terms of a z-score. So what that means is each person's value, instead of being an actual raw value, will be its distance in standard deviations from the mean. And so people will have things like -1, 2.5, 3, -0.7. And what that means is for that person, the score that they had was that distance from the mean. Okay, I'm going to run this. And you can see it gives it to you in a different format. So here you have your variable here, and everything is displayed in columns. Up here in frequencies, you had your variable up top, and then everything is displayed in rows. But we're getting the exact same information here. So this is just another way of getting that same information. Okay, and then the last thing I want to show you is how to get that confidence interval for these things, because that's really the most important part of this week's lesson, is getting the confidence interval. So we're going to go to Analyze, Descriptive Statistics, and then to Explore. So we did frequencies first, descriptive second, and we got the same thing from both of them. Explore is going to give us a new option. And so we're going to move number of hours into our dependent list. Don't worry too much about this, but we're going to choose the dependent list. We're going to go into statistics, and it's already by default going to give us a confidence interval. But what you can do here is change whether you want that confidence interval to be 95, 99, 90, and it will give you that confidence interval. So actually what I'm going to do is I'm going to do 90 for now. I don't think we actually need to look at any plots right now, so I'm going to turn off the plots piece and ask it to just display me the statistics. And I'm going to paste that. And so what it does when I paste that is it puts it into our syntax window. And then what I'm going to do is see if it will let me do this way. If not, I can just do a new row of syntax. So I'm asking it to give me 90, 95, and 99% confidence intervals. I'm not certain that it will do it all in one run, in which case I'll make different blocks of syntax for that. No, so the answer is no. It would not give it to me all at once. So what we got, So what it did was it gave us, so you can see here, it gives you warnings. Those warnings also show up at the bottom of your syntax menu if you're using syntax. And the warning says multiple C interval subcommands encountered. When conflicts exist, the last subcommand will be used. And so what that means is it didn't want us to put 3 of these here, and so it used only the last one. So what we got was the confidence interval for the 99%. So I'm going to delete these 2. And what I'm going to do is I'm going to copy this syntax, paste it again, and then paste it again. And I'm going to change this 99 to a 95. And I'm going to change this 99 to a 90. And so now when I run these 2 as well, I'll have confidence intervals for 99, 95, and 90. Okay, so now we have all of our output, and we scroll up a bit and we go back to the original one, which was the 90%. So this Explore is giving you a lot of information. So Explore is by default giving you the mean. It's then giving you the confidence interval for that mean. So the confidence interval for that mean for 99% is 14.5, 21.8. It gives you the median, the variance, the standard deviation. The only thing it doesn't give you here, oh, actually, I'm sorry, I'm wrong. It does give you even the standard error. So the standard error of the mean is over here. So really, if you're trying to do these kinds of descriptives of data, and you want the mean, you want the standard error, and you also want a confidence interval, the Explore menu is actually the best place to go to get all of this information at once for a continuous variable like this, if we can assume a normal distribution. Again, in this case, we shouldn't be assuming a normal distribution of this variable because it was not normally distributed. But we're going to go ahead and just pretend that it's normally distributed for the sake of showing you how to do these things. So if you encountered a variable like that in real life, you would not want to make the assumption that it's normally distributed. Okay, now in the next set where we have the 95% confidence interval, obviously I just want to point out the mean is going to be the same, the standard error is going to be the same, the median is going to be the same, the standard deviation is going to be the same. All of these things are going to be the same. The only difference is that the margin of error has changed, and so therefore we're actually going from the direction of more confident to less confident. And so what that's going to do, as we talked about before, to our confidence interval is actually make it narrower. So we're going to get closer to the mean because we're going to be getting less confident. Before we were trying to get more confident, and so our confidence interval was growing, getting further away from the mean. Now our confidence interval is going to shrink a bit and get closer to the mean because we're going to be getting less confident. So 14.5 and 21.8. Now we have 15.4 and 20.9. That's for 95%. And then it's going to get even narrower for 90%. So 15.8 and 20.4 is actually not much narrower than our 95%. So we didn't really move in as much when we went from 95 to 90 as we did when we went from 99 to 95, but still some definite movement towards getting narrower or less wide as we get less confident. So the size of the width of the confidence interval changes in the same direction as the confidence. So to get more confident, we get wider. To get less confident, we get less wide, also known as narrower. Okay, so that is pretty much everything that I had to show you for this evening. Again, if there's any confusion about means and standard deviations and standard errors, please go back and try to watch last week's videos. I will take the time tonight to also post some Khan Academy videos about confidence intervals, which are external videos. I've posted Khan Academy videos for some of our other topics before. Hopefully some of you are watching them and finding them helpful. If you don't need the extra help, then by all means don't feel the need to watch them. But I do just post them there because he explains things in a way that's, I think, probably different than the way that any of us are explaining them. So I like to put those there for people who are really struggling. It might give you just the different twist that you need on the topic to really help you figure it out. Other than that, I will have the spreadsheet and this SPSS dataset posted within a few minutes. And I hope you all have a good night. Thanks.